2005 Canadian Open Mathematics Challenge, Part A. Determine the value of 10 squared minus 9 squared, and so on. Well, this question you can do it manually, right? But hey, let's have a little bit of fun with it. Let's break it into pairs like that, and each of these pairs will be able to be factored pretty nicely, right? 10 minus 9, 10 plus 9. And then this one, of course, 8 minus 7, 8 plus 7. The next one would be 6 minus 5, 6 plus 5, and so on. So you'll have 4 minus 3, 4 plus 3, and then finally 2 minus 1, 2 plus 1. So what that does is allows us to make all these ones. That becomes 1 in 19, 1 in 15, 1 and 11, 1 and 7, and finally 1 and 3. And now you can add this. 3 plus 7, that's 10, 10, 21, 21 and 19 is 40, and 40 and 15 is 55. So whichever way you want to do it is fine. I just did it in this way because it's a little cooler. A bug in the xy plane starts at point 19. It moves first to the point 210 and then reaches the point 311, and so on. It continues to move in this way until it reaches a point whose y coordinate is twice its x coordinate. What are the coordinates of this point? So it starts off at 19, and then it goes to 210, and then it goes to 311, and so on, right? So it's moving along. So that looks to me like if you were to make a little table, each of these is going up by 1. So I want a relationship between the x value and the y value, and it looks to me like they're always, sorry, that was 311. They're always, if that is indeed 11, they're always 8 apart. So these are always of the form a plus 8, right? Because the next one would be 412, and that is also a plus 8 in that form. So what they want is you to figure out when the y coordinate is twice the x coordinate. So when is it so that a 2a is the scenario, the y coordinate being twice the x coordinate? Okay, we'll just compare those. That means that a plus 8 would have to be equal to 2a. So a plus 8 would be equal to 2a. And if that's the case, 8 is equal to a. And therefore the coordinates would be, 2a would be 16. So the coordinates would be 8, 16. And that's it. If x to the power of 3 times a plus bx squared plus cx plus d is equal to x squared plus x minus 2 times x minus 4 minus x plus 2 times x squared minus 5x plus 4 for all values of x, what is the value of a plus b plus c plus d? Okay, so I guess the first thing is we have to expand this. So this side will just stay the same, and then we've got to expand that whole big thing. Okay, let's do that. So we get x to the power of 3 minus 4x squared plus x squared minus 4x minus 2x plus 8. And then minus, so we've got to put this in brackets, x to the power of 3 minus 5x squared plus 4x plus 2x squared minus 10x plus 8. Okay. And then we got to, collect like terms and all that. So x to the power of 3 minus x to the power of 3 minus 4x squared plus x squared plus 5x squared minus 2x squared minus 4x minus 2x minus 4x plus 10x plus 8 minus 8. All right. So this becomes 0. So 0x to the power of 3. This becomes, let's see here, 0 again. 0x to the power of 2. This is 6 and what was this symbol here? This was a minus, right? Yeah. So that becomes 0 again. 0x, and this is 0. Interesting. So if you compare these coefficients, it looks to me that a is 0, b is 0, c is 0, d is 0. So therefore a plus b plus c plus d is 0 plus 0 plus 0 plus 0, which I believe is 0. Okay, interesting question. A fraction p over q is in lowest terms if p and q have no common factor larger than 1. How many of the 71 fractions, 1 over 72, 2 over 72, ... are in lowest terms? All right. Well, 72 is the denominator, so we have to first look at what are the factors of 72. It is 2 times 2 times 2 times 3 times 3. So 2 to the power 3 times 3 to the power 2. Okay. So that means that anything that's in the numerator that is either a multiple of 2 or multiple of 3 will not be in lowest terms. For example, the one right there, the numerator is a multiple of 2. It's 2 itself. And obviously 2 over 72 can be reduced to 1 over 36. So that means that anything that's a multiple of 2 will be reducible. So that means all even numbers will be reducible. So I'm just going to concentrate on the odd ones. So let me just write that down. All even numerators will be reducible. Okay. So I'm going to just concentrate on the odd ones. And there's not that many, right? 1, 3, 5, 7, 9, and so on. So I'll just list them all out. So that's the full list, right? So let's start talking about this. We already got rid of all of the even numbers, and we're just left with all the odd numbers. Now, let's concentrate on the factors of 3. Any factor of 3 will also be reducible. For example, 3 itself over 72 will be reducible, right? It'll be 1 over, 24? Yeah. And similarly, any multiple of 3. So get rid of the multiples of 3. So 3, 6, 9, 12, 15, like that. So 15, 21, 27, 33, 39, 45, 51, 57, 63, and 69. And I think that's it. I'm trying to think here. Is there any other scenario? Just multiples of 2 and multiples of 3, right? Okay, well, let's count what's left. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So 24 of these fractions are in lowest terms. Yeah, I think that's it. I for some reason I'm second guessing myself, but I'm pretty confident that this is the correct answer, 24. All right, next question. An office building has 50 stories, 25 of which are painted black and the other 25 of which are painted gold. If the number of gold stories in the top half of the building is added to the number of black stories in the bottom half of the building, the sum is 28. How many gold stories are in the top half of the building? Okay, so we've got to create some equations entirely based on what this building is like. So we got a top half and we got a bottom half. So I'll call the gold in the top GT, the black in the top BT for obvious reasons, gold in the bottom GB, and the black in the bottom BB. Yeah, might as well. Okay, so based entirely on the information in the question, they tell me that the total is 50 stories. So all of these, if you add them up, have got to equal 50. So all of these are equal to 50. Then they say 25 are black, right? 25 are black. So that means just the black ones, BT plus BB, are 25. And similarly, 25 are gold. They told me that also in the question. So GT plus GB is 25. And then what else do they tell me? That if you take the gold in the top and the black in the bottom, it's 28. Okay, so that means that GT, gold in the top, so GT plus black in the bottom, so that's BB, is 28. Anything else? That's 4. Oh yeah, right. These two are in the top. So the top half is 25, correct? So GT plus BT is 25. And similarly, these two are in the bottom half. Yeah, top half, bottom half. So obviously the bottom half is 25 since the total is 50 stories. And therefore GB plus BB is 25. So all of these equations we got entirely based on what's written in the opening stem. I didn't actually do anything so far. I just wrote down, what they've told me into an equation format. Okay, so now we can proceed. How many gold stories are in the top half? So what they want you to find, gold stories in the top half, so that's GT. So they want you to find this guy. Okay. So where do I proceed? Which equation do I use? Obviously one with GT in it, GT, BT. So I'll use this one here. From that, GT is equal to 25 minus BT. Okay, I think that's a pretty good start. From the next one, we conclude that BB is equal to 25 minus GB, right? So 25 minus, GB, if you look at this guy, is 25 minus GT, because I'm trying to get the GTs in there because that's what we're trying to figure out. So 25 minus GT. So that means 25 minus 25, so this becomes GT. So BB is the same as GT. Okay, that's pretty helpful, I think. So then now we're going to use this one. This one was given for a reason because we want to use it. GT plus BB, BB is the same as GT. So GT plus GT is 28. So 2GT is 28. So therefore GT is 28 divided by 2, which is 14. And that is the answer. In each grid shown, each row has a value assigned to it, and each column has a value assigned to it. The number in each cell is the sum of its row and column values. For example, the 8 is the sum of the value assigned to the third row and the value assigned to the fourth column. Determine the values of x and y. All right, so let's just look at this here. The key in this is that there's some values assigned to each of these rows and columns, and those values then are added up to find each specific entry. Okay, so the first thing I did was that I looked at this. I just sort of said, okay, A, B, C, D, E, these are the values assigned to those rows. So this is row 1, right? Row 2 is B. And then similarly, the columns, whatever letter you want to use, F, G, H, I, J, those are the values assigned to those columns. So for example, the 3 was obtained by adding A plus F. You see what I mean? The negative 2 was obtained by adding B plus F. So we have no idea what A is, what B is, what F is, but I just wanted to show you. Similarly, C plus F would be 5, and so on, right? So when I looked at this, I thought, is there any trend when you're going down here, when you're going down this list from 3 to negative 2 to 5 to 0? And I thought, okay, well, let's see here. When you go from 3 to negative 2, obviously you've gone down by 5. So this was minus 5. And then when you go from negative 2 to 5, you went up by 7. So plus 7. When you go from 5 down to 0, you went minus 5. And then when you go from 0 to negative 4, you went minus 4. And then I looked at the next one, and it has the exact same. Went down by minus 5, right? 0 to negative 5. Then from negative 5 to 2, you went up by 7. From 2 to minus 3, you went down by negative 5. From negative 3 to negative 7, you went down by minus 4. And you'll see that the same thing should hold true for all of these. Let's see for this one. This is the other one that has just numbers. 6 to 1, you went down by minus 5. 1 to 8, you went up by 7. 8 to 3, you went down by minus 5. And 3 to negative 1, you went down by negative 4. So it all is the same. So that means when you go from here to here, you go down by minus 5. When you go from here to here, you go up by 7. From here to here, you go down by minus 5. And from here to here, you go down by minus 4. So that means that minus 2 minus 5 is my y. Right? You had minus 2 and you went down by minus 5, so you get down to y. So therefore y is minus 7. And then where's the x? X is here. You're at 0, and to go from 0 to x, that step is going up by 7. So 0 plus 7 is x, so therefore x is 7. And I believe that is all they wanted. They wanted the value for x and y. And x and y are, determine the values of x and y. So I got y to be, y was negative 7. For some reason, the negative disappeared there. Y is negative 7 and x is positive 7. So that is it. In the diagram, the semicircle has center O and diameter AB. A ray of light leaves a point P in the direction perpendicular to AB. It bounces off the semicircle at point D in such a way that PDO angle is equal to angle EDO. In other words, the angle of incidence equals the angle of reflection at D. The ray DE then bounces off the circle in a similar way at E before finally hitting the semicircle again at B. Determine angle DOP. Well, first thing is I'd like to connect these dots here. That one. And let's talk about this now. So they told me that perpendicular to AB. So that means this is a right angle right here. Okay. Then we got to label this. This angle in here, I don't know, so I'll just call it theta. And then they're telling me that it bounces off the semicircle at point D, which is right here, in such a way that PDO equals angle EDO. So PDO is equal to EDO, so this is also theta, this angle in here. Entirely based on what they told me. And then, let's see here. This is a semicircle, right? Yeah, so this is a semicircle, so this blue line is the radius. Yeah, because O is the center. And similarly, this blue line, well, that's also the radius. So that means this is an equilateral, isosceles triangle. I got to learn my triangles. So that means this angle is also theta. That's a property, right, of isosceles triangles, that those two angles are the same. Okay, that's very helpful, I think. And then if you read this sentence, the angle of incidence equals angle of reflection. When we get to here, this is the angle of incidence, and then therefore this would be the angle of refraction, and since the angle of incidence equals the angle of reflection, this is also theta. Yeah. Okay, so now what we have to do is something known as angle chasing. We have to sort of fill in all the angles and let's see what we get, that kind of thing. All right, it shouldn't be that big of a deal. Let's see, where can we go here? Well, I'll just fill them in. That angle in there is going to be 90 minus theta, because the sum of the angles of that triangle are 180. This angle in here is 180 minus 2 theta. And then this angle in here, that's an interesting one, because that's 180 minus this and this. So I'll do it on the side here. 180 minus 90 minus theta. minus 180 minus 2 theta. So that looks to me like 3 theta minus 90. So this angle right here, 3 theta minus 90. And then this one is going to be 180 minus theta minus 3 theta minus 90. So that's going to be 90, or sorry, it's minus, so it'll be 270 minus 4 theta. Yeah, 270 minus 4 theta. Okay, great. We got it all labeled. All right, so where do we go from here? This is also the radius right here from O to B. So since O to B is also a radius, that makes this an isosceles triangle. Aha. So that means this angle is the same as that angle. So that means theta is equal to 270 minus 4 theta, and therefore 5 theta is equal to 270. Theta would be 270 divided by 5 is 54. Okay, great. And what do they want? Determine DOP. DOP, angle DOP is 90 minus theta. Okay, so that's 90 minus 54, which is 36. 36 degrees is the angle DOP. The number 18 is not the sum of any two consecutive positive integers, but is the sum of consecutive positive integers in at least two different ways, since 5 plus 6 plus 7 is 18, and 3 plus 4 plus 5 plus 6 is 18. Determine a positive integer less than 400 that is not the sum of any 11 consecutive positive integers, but is the sum of consecutive positive integers in at least 11 different ways. Let's concentrate on the fact first that this number, whatever it is, let's just call it A, and A they're saying is less than 400, is not the sum of any 11 consecutive positive integers. So A is not the sum of 11 consecutive positive integers. Let's just start off with n being the first one, and therefore n plus 1, n plus 2, and so on. So that is 11 consecutive positive integers. And when you add this all up, there's going to be 11 of these n's, and then 1 plus 2 all the way to 10. You guys remember that formula, right? Consecutive integers, 1 plus 2 plus 3, dot, 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 all the way up until k is equal to k times k plus 1 over 2. So that's just going to be 10 times 11 over 2. And therefore that's 11n plus 55. So A is not equal to that. Now if you factor out the 11, you get n plus 5. So that means that A is not equal to that. Therefore, we can conclude that A is not divisible by 11. Because if it was equal, it would be divisible by 11, but it's not. Okay, that's the first thing we've established, and that will help us. Just that point, that A is not divisible by 11. Now, what we have to do at this point is we've got to create a scenario where A is the sum of 11 different ways, consecutive integers. So perhaps 2 consecutive integers, 3 consecutive integers, and so on. So let's make a table. So now we have to fill in this table. So here we put the number of consecutive integers. So the number of consecutive integers, for example, let's say it's 2, 3, and so on, right? So this is going to be how many we think it could be. Now 11, we just figured out, is not possible, right? That they told you that in the question. So 11 is something we don't need. But I'll just put it in there, but we know for a fact that that's not going to be one of ours. So let me just fill in all of this. So I went up to 30. Hopefully we can figure this out by 30. I hope we don't have to go longer than that. Now the second column is the sum, right? So if we have, for example, 2 consecutive integers, n plus 1, that sum is 2n plus 1, correct? So that means that A is equal to 2n plus 1. And therefore, what is our conclusion? So in this case, the only thing I can conclude that A is odd if it's 2n plus 1. Okay? How about 3? Then it would be n plus 1 plus n plus 2 if it's 3 consecutive integers. And that is 3n plus 3. And if you factor out a 3, you will get 3 times n plus 1. And therefore, it's divisible by 3. So divisible by 3. So a lot of these are going to be divisible by, except this one. This one just sort of told me that it's odd. But a lot of these will be able to get it's divisible by something. Let's keep going here. So I won't bore you with the details. I'll just do a few more. Similarly, if it's 4 consecutive integers, n plus 1 plus n plus 2 plus n plus 3, right? 3 consecutive. When you add those up, it's 4n plus 6, and that can be, a 2 can be factored, so 2n plus 3. So that tells you it's divisible by 2. So if it's divisible by 2, then it's even. So I already got a little bit of a contradiction, but that's okay. But you'll see that once we fill this table out, we'll have to choose 11. If we can get 11, we're done with the question. And then we have to figure out what A is. And that shouldn't be too much of a problem. So what I'll do is, or I have to do a couple more. So when A is, when the number of consecutive integers is 5, this will be 5n plus 10. You can factor out a 5. And that will be n plus 2. And therefore that tells me that is divisible by 5. Divisible by. Do a couple more. When the number of consecutive integers is 6, this becomes 6n plus 15. That is 3 times 2n plus 5. And that tells me it's divisible by 3, which is a result we already got up here. So that's good. There's at least some consistency. 7 is 7n plus 21, which obviously is divisible by, is factored, you can factor a 7. So that's 7 times n plus 3, divisible by 7. All right. So I'll just fill this out all the way to the bitter end. And it's done in the same way, so I'm not going to be doing anything different. So I'll come back and talk to you. So there you go. There's the entire table. So there was no tricks in filling out this table. I just did the exact same thing as I did for the first few that I showed you. Okay, so now let's talk about this. We've got to choose 11 of these. Hopefully we will get 11 within these 30. Now, it's odd or even, so I've got to make a decision. Which one is it going to be? Am I going to choose an odd, or I'm going to choose it to be even? Well, when I go through this list, I see 5, 3, 7, 4, 9, that should be a 5. And then 6, 13, 7, 15, and so on, right? So I see more odds than evens. So that makes me think that I probably got a better chance of getting 11 if I choose it to be odd. So I'm going to choose it to be odd. Okay. If it's odd, then can it be divisible by 3? Sure, because 3 is odd. Even is out, so we're not going to choose that one. And then 5, I'll choose that. 3 is good. 7 is good. 4 is no good. So I can't choose 4 because 4 is even. So let's get rid of that. We're not going to choose it. 9 is fine because 9 is odd. This 5 is fine. 6 is even, so I can't choose that. 13 is fine. This is fine. This is fine. 8, can't choose that. 17 is fine. How many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ah, I've got 11. Okay, let's see if I can figure out what A is. So A is going to be, if I choose these 11, it's got to be at least a 3. So, right, this is 3. Then 5. Then the 3 is already there. Then a 7. Then a 9. Well, I can just tack on a 3 here to get divisible by 9. Then a 5 is already there. 13. Okay. Then 7 is already there. 15 is 3 times 5, so already I have that in there. and then a 17. Okay, so this is my A. But something tells me this is going to be way more than 400, because remember, A had to be less than 400. No problem. Let's just figure out what it is. This is 3 times 3 times 5 times 7 times 13 times 70, 69,615. Ah, okay, well, nice try, but it's not even close to being less than 400. Okay, no problem. Let's just keep going here. So we tried up until here, and we failed. Well, I failed. No problem. Let's keep going. Okay, my gut instinct is that in order for this number to be less than 400, we can't use such big factors. You see that's pretty big, that 13 and that 17. So what I'm going to do is I'm going to go back and I'm going to choose small numbers. Okay, I'm going to stick with my decision for it to be odd, divisible by 3. 3 is a small number. I'll stay with 5, 3, and I'll even stay with 7. And then 9 is just going to be 3 times 3. The 5 is fine, but I'm not going to choose this 13. I'll choose the 7. 15 is 3 times 5, so I'll have that automatically. I will not choose the 17. 9. Well, 9 is 3 times 3, and that's a tough one. Should I choose it? Well, yeah, because I already have 3. 3 times 3. Yeah, I've got a 3 and I've got a 3, so I can choose that. 19 is too big, so I'm definitely not going to choose that. 10 would involve a 2 and a 10 and a 5, but 2 would make it even, so I can't use that. 21 I think I already have. I've got 3 times 7, so I've already got this. So let's try now. So do I have 11? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Yeah, I got 11. So let's see what A is. I'll do it down here. A. Okay, it's odd. That's fine. Divisible by 3, this guy right here. So we got a 3 in there. Next one, divisible by 5. Okay, times 5. Next one is 3. Well, we already did. 7. Okay, this one. Then divisible by 9. So that I just got to put another 3 in there, because 3 times 3 would make it 9. Divisible by 5. We already got a 5 in there. Divisible by 7. We have a 7. Divisible by 15. That's 3 times 5. We already have that in there. Next one was 9. We already have that. That's 3 times 3. And the final one was 21, which we have because we have a 3 and a 7. Okay, this looks promising. So 3 times 3 times 5 times 7 is 315. There you go. That fulfills the criteria that A is less than 400. We have shown that therefore A can be written as a sum of consecutive integers in 11 different ways, namely 2 consecutive integers, 3 consecutive integers, 5 consecutive integers, 6, 7, 9, 10 consecutive integers, 14 consecutive integers, 15 consecutive integers, 18 consecutive integers, and 21 consecutive integers. And yeah, and it was not able to be written as the product of 11 consecutive integers, and nowhere in this have we shown that A was divisible by 11. So there you go. That completes a very cool and challenging question. Number 8.